Hello and welcome once again. In the next few videos, we will study about MOS amplifiers, their operation, circuit diagram, input-output characteristics, small signal analysis and amplifiers voltage gain. All we will see one by one. The amplifiers we will study are common source amplifier, common drain and common gate amplifiers. This video is about the common source amplifier. So let's start with it. So first of all, let's understand that why it is called common source amplifier. Look at its circuit. Here this is a source terminal, this one is gate and this one is the drain terminal. So input is applied at the gate and output is taken from drain terminal, where source terminal is common to both input and output sides. Therefore, it is called common source amplifier. Now talking about its operation, that because of its transconductance, the MOSFET M1 converts changes in its gate source voltage, that is the input voltage, to a small signal drain current which passes through this load resistor and generates an output voltage. So this is the amplifier's principle of operation. Now let's see its input-output characteristic. As we can notice in the plot that when input is lesser than threshold voltage, M1 is off, and in this case Vout will be equals to VDD. Now when this Vin approaches VTH, this threshold voltage, then M1 begins to starts conducting, or you can say turn on, and it will start drawing current from the load resistor RD, which lowers down the output voltage from VDD. Here M1 is in saturation. This you should note the point that M1 is in saturation, and so we can express this V out by this equation: VDD minus RD, load resistor, half mu n Cux. This one is the drain current ID, mu n Cux, W by L, which is called aspect ratio, Vin minus this threshold voltage, iska whole square. Now with further increase in the input voltage, this V out drops more and M1 continues to operate in saturation until Vin exceeds V out by VTH. This is denoted by the point A. At this point A, we have this equation number 2. So after this point A, as Vin is increased, M1 enters into the triode region. Triode region current equation is this one. So the V out is given by equation 3. So this is about the input-output characteristics of resistive load common source amplifier. Now let's find out the voltage gain from this input-output characteristic. As we know that the voltage gain is simply given by the slope of the input-output characteristic. So now differentiating both sides of this equation 1 with respect to Vin, we get the voltage gain. Here this is the transconductance, mu n Cux, W by L, Vin minus VTH. Here you can note that this voltage gain is depending on two factors, the transconductance and the load resistor, where this transconductance GM is proportional to the aspect ratio or the size of the MOS M1. So larger the device, we will have large voltage gain with trade-off of chip area. And as we increase this resistive load, the voltage gain will also increase, but power dissipation and parasitics will also increase corresponding to this load resistor. Now moving ahead towards the small signal analysis. The small signal model of the common source amplifier is very simple. So in this diagram we have ignored this channel length modulation resistance. So the V output is given by minus GM V1 RD. This is our equation 5, and V1 is actually the input voltage. So this voltage gain is again comes out to be minus Gm Rd, which we have already seen in the input output characteristic. Here take some time and try to redraw the small signal model while considering the channel length modulation resistance RO. Since source terminal is grounded, so this channel length modulation resistance and the load resistance RD becomes parallel, and in the final expression of voltage gain we have minus Gm RO parallel RD. So this one is our final output resistance of common source amplifier with resistive load. Here you should note the point that value of RO is in mega ohms, and it depends on the size of M1. Moreover, the input impedance, you can see the input impedance of this resistive load common source amplifier is very high. You can note it. So it is very high because we have insulated gate. Output resistance or output impedance is RO parallel RD, or you can say approximately just RD. Here I am winding up resistive load common source amplifier. In the next video, we will study about the diode connected load common source amplifier. For upcoming videos, please like and subscribe the channel. Thank you so much and have a nice day.